The following rare film excerpt highlights the IBM 701 electronic data processing machine of 1953, the first in IBM's successful 700 series. The original film was silent, so we have added a bit of narration. The vacuum tube-based IBM 701 was a high-speed computer that was designed to solve large problems in scientific and engineering computation. 19 systems were made in total. Today we are looking at a partially restored IBM film segment, showing the IBM Model 701 Defense Calculator, which was announced in 1952, as the IBM 701 electronic data processing machine. It was developed at IBM's Poughkeepsie Laboratory in New York. This was the first in IBM's 700 series of high-speed computers and first in the line of IBM's commercially available electronic computers. 19 complete systems were manufactured beginning in 1952 and were typically rented for about $12,000 to $15,000 per month, equivalent to about $140,000 to $175,000 per month today. Designed primarily as a scientific computer, IBM 701 competed with the UNIVAC 1103, which had been designed earlier by engineering research associates for the U.S. Navy. In tests requested by the Navy, the 701 demonstrated slightly faster processing speed, but had slower input-output than the UNIVAC 1103. Research indicates that 19 of the IBM 701 systems were ultimately manufactured, compared with about 30 or more of the competing UNIVAC systems. However, in cases where computers were manufactured for national security purposes, exact production numbers may not be publicly available. The 701 was a 36-bit, parallel machine, with internal binary operations. However, input-output units could also handle alphanumeric and decimal data. A special feature of the system was its electrostatic storage memory, provided by an array of Williams-Kilburn tubes which were specially designed CRTs. Shown here is the IBM 706 unit, containing 72 CRTs, with removable drawers for servicing. This cabinet provided 2,048 words of high-speed memory storage, but it was unreliable and ultimately replaced by magnetic core memory in the more advanced computers that followed. In addition to the electrostatic memory, the system used a Model 731 magnetic drum unit containing 2 physical drums, configurable into 4 logical units, plus 2 Model 726 magnetic tape units, a Model 721 punched card recorder, a Model 711 punch card reader, and Model 716 continuous feed printer. In all, the system used about 4,000 vacuum tubes and several power control units. Total system weight could easily exceed 25,000 pounds. Shown here are the vacuum column chambers designed by IBM engineers that provided buffering and stress relief for the tape as it traveled at high speed through the tape machine. This helped allow higher recording speeds without damage to the tape itself. Tapes were half an inch wide and 1,400 feet long, with 7 recording tracks, 6 for data, and 1 for error checking. Shown here is a close-up of the 2 magnetic drums. This unit itself weighed about 1,500 pounds, providing about 82,920 digits of storage. You can see the switch on the left, indicating 4 logical divisions. A few words about the 700 series. Whereas the 701 was primarily designed for scientific and engineering calculations, including military, aerospace, energy and large data applications, the 702, 1953, targeted business data processing tasks like accounting, payroll, and inventory management. The 703, 1952, was a specialized computer designed for IBM's internal use in scientific and engineering R&D and was never commercially available to the public. The 704, 1954, was a highly successful scientific computer, with significant improvements including floating-point math, and improved complex scientific and engineering calculations. The 705, delivered in 1956, utilized magnetic core memory and offered improved data processing capabilities especially in accounting, payroll, and inventory with greater efficiency. The later IBM 7000 series, introduced in the late 1950s, used transistorized systems providing greater reliability and lower maintenance and support costs. IBM produced 19 of the 701 computers, and installed them at the following sites: